Hello, today we are going to follow up on the Michael addition, 1,4 conjugate addition, and look at the Robinson annulation. This is a two-step reaction that is a 1,4 conjugate addition of an enolate with another ketone, followed by an aldol in one pot reaction. So we're going to take a look at the mechanism. The first step, we add a base, which will remove the most acidic proton. In this case, that's this proton. This is now our nucleophile, and it is a conjugated system. It's resonance stabilized, so it will do a 1,4 addition. That gives you the product. You can draw as the enolate with the minus here or resonance over the oxygen. And then this product. Now there are a couple of proton transfers that occur because this could react with that ketone, but that would form a 4-membered ring, and we remember that that is not stable. So we find that under equilibrium, this will get protonated, forming this structure. Base will then pull off this proton on the opposite side of this ketone, and this will react in an aldol. At this point, you form the ring. That's why it's called an annulation. That means ring. It's often useful to count carbons when you're doing this to make sure that, for example, from here to this carbonyl, there are 2 carbons in between, so that we make sure we get things in the right place. This alkoxide, can be protonated. Grab that proton, and we form the alcohol. Under basic conditions, this tends to undergo a condensation reaction, ending up with the enone. Often you'll be asked to do this same Robinson annulation, but in reverse. Predict the starting materials. So remember, the last step of that aldol condensation was to form the double bond. So we know this is the double bond that was formed. The OH must have been here. So for the Michael adduct, we know that we could, if we go backwards, this ring was here. This ring, this part of the carbonyl was still here, but we made this bond, and this was the carbonyl. So this was the enolate anion that attacked in the aldol. Now, if we go back further, we remember that the first step was a conjugate addition, and that the electrophile was a 1,4, and so this is the bond that was made. So the 1 has to be a 1,4 conjugated system, or unsaturated ketone, and this is usually the diketone.